Hello and welcome back. In the previous problem, I discussed an application of the Biot Savart's law, and I was about to talk about the direction of magnetic field. But what happened was I did, but it wasn't all that accurate, and I wasn't that clear, I think. So I'm making another part. This is part 2 to that previous problem, and we're going to be discussing the direction of magnetic field at point P from the previous problem. So I'm going to reconstruct what we did there. So just to jog your memory, we have 3 current carrying conductors, 1, 2, and 3, and we have to check the magnetic field at point P due to these 3 current carrying conductors, and they're carrying a current of I amps. So what we did calculate in the previous part was, because of 1 it's 0, because of 2 it's mu naught I over 16d, and this is d here, and the third part was again 0 because they're anti-parallel, the unit vectors. I mean, it's pretty simple, and if you follow the previous, the part 1 of this 2-lecture series, you'll understand what's happening. So I'm here to talk about, in this part, we're going to talk about the direction of magnetic field at P. Right? The fourth part was the net magnetic field, and which is the same as 2 because the others, the first and the third are 0. Right? So we know this. So right now we're going to apply the right-hand rule to this problem and figure out exactly what the direction of magnetic field at point P is. All right. So let's first talk about the first conductor. Right. It looks like this with the current flowing in that direction. Right. So the right-hand rule says if you point your thumb in the direction of the current, the way your fingers curl around a conductor, that's the direction of magnetic field. So so let's see here. If your right hand is like this, your fingers would go like this, right? Holding the conductor. So if you actually see how your fingers are curled around the conductor, you'd see that they're coming out of the page in this part of the conductor, and going into the page in that part of the conductor. Do you see that happening? I hope we're clear about the notation of coming out and into the page. So this is into the page, and this is coming out of the page. Right, so if you wrap your fingers around it, this is how it's going to go. Basically, if you look at it from this point, the conductor, your magnetic field lines would be this way, right? Going in that direction. Wow. Hold on just 1 second. It looks really indiscernible. Let me try. Okay. So the magnetic fields are going in that direction. Do you see that? So coming out of the page from here and going into the page there, right? That's what's happening there. So similarly, for the third conductor, if we see, right? So they'd be coming out. Your fingers would be coming out on this side and going into the page on this side, right? And if you see, this is for conductor 3, this is for conductor 1, and if you see conductor 2, and you point your thumb in the direction of the current, right? So the way you're gonna see this magnetic field is your fingers are gonna go inside the page on this way, on this side of the conductor, and will come out of the page this side of the conductor, right? So I hadn't spoken about where it goes in and from where it comes out in the previous lecture that I made, and I now deleted. So yeah, this is very important. Sorry, this is the second conductor, right? And if you look at our problem, point P is on the part of the is on the side of the conductor to where the magnetic field is going into the page. Do you see that? So let me draw that here as well, right? The magnetic field is going into the page here, right? So the magnetic field at point P is going into the page. As simple as that. That's all I wanted to say. But yeah, if we talk only about into or outside the page when we're wrapping around a conductor, it becomes slightly confusing. What we have to remember is when we have a current carrying conductor and we want to see the magnetic field direction, it's going to be different on two sides of the conductor. That's what I'm trying to stress on. Okay, so I hope that's clear, and pretty soon I'm going to be making another lecture on another interesting problem. Thanks.